All right, so our latest project, we're going to be checking out this B&K amplifier. This is model ST-260, and this unit belongs to Scott. He lives in Pennsylvania, and he got in touch with me after seeing one of my videos for a B&K receiver. He's saying what happened is he had some type of catastrophic electrical problem at his house. His B&K receiver did survive with no problem, but unfortunately after everything was said and done, this unit now has a dominant hum in both channels when you turn it on. So a couple of things definitely come to mind with that type of symptom. It's a very simply stated amplifier, and there's not really much to see in the front, so I think we'll start the video off by taking a look at the connections in the back. He says he uses this for powering a set of bookshelf speakers, which seems to be about the right application for an amplifier this small. So once we get it opened up, we'll see if we can figure out what happened to it. As for our intro music, we're checking out the 2018 release by Red Dragon Cartel titled Patina. And of course, this is guitar virtuoso Jakey Lee's project, and they had an album before this one that was excellent. We're gonna check out a little bit of my favorite track from this. This is called The Luxury of Breathing. We'll hear a few seconds of this, and then we'll get started on the B&K. All right, let's go ahead and pick back up and we'll have a look at the connections provided on the back of the unit. Starting on the far left here, they do have an integrated grounded power cord receptacle with a built-in cartridge type fuse holder. We'll go ahead and pull this out, but if he does have a dominant hum, then I would imagine his fuse is good, and it is good. So we'll put that back. Starting over here in the center, upper center, we have the level controls for the right and the left. Right below that, the speakers for the right and the left. They mark them with the actual words, plus and minus. Right above that, bus input, basically just the input from whatever you're sending a signal out of into this unit. And then they have bus output here, which basically you can come into this amplifier if you want via right and left channel and then go right back out to another amp or come out mono into a different amplifier. Then over here we have control in and out. Basically what this is, we'll read what it says here. When switch is set to enable, the amplifier will only operate while a 5 to 24 volts DC signal is being applied to the control in. Now, I've never seen control in and control out with these type RCA jacks. Most of the time that's a 3.5 jack, but here they're using RCA jacks to do that with. So I would imagine that on the back of a B&K receiver there may be a control jack with RCA type of style jack on it for you to use with this amplifier. So again, very simply stated, not a lot going on here. Let's go ahead and get the lid off of it. Let's get it plugged up and we'll monitor the output and see what kind of voltage we got there. So at this point, there is no need to torture speakers. If we have hum, we know something's going on. So give me a second for that and we'll come back. All right, before we turn it on, let's take a quick look at the inside of the unit. Basically, we have our AC power coming in to a small connector block here, which also has a connection from the switch, and a wire lead going all the way around into the control in and control out. Very nice transformer for this size amplifier, and a power supply that's about as small and as simple as it gets. We have two Nippon caps, 10,000 mic at 50 volt, a full wave bridge rectifier, and two fuses. That's pretty much it for the main power supply. There's a few power supply components up in here for the input section of the amplifier. And as for the actual outputs, not a discrete amp. You get two output devices here, pretty much AFPOs. And let's see if we can get a fix on the number of one of those. Looks like LM3886T. I'm not sure if that's ST micro devices or maybe Texas Instruments or Philips. I'm not sure. We'll have to look into that. But one of the things that I'm noticing looking through this circuitry is there isn't anything that appears to be burnt up or smoked or blown apart. But this is what happens when you turn it on. I've got leads of the meter in one side of it. Push the power switch and this is what you get. Negative 37 volts, that's one channel. And that's the other channel. So we got a negative on one side and a positive on the other side. Almost like there isn't, you know, there's a direct connection straight from the power supply into the output section. So I think the first thing we probably want to do here is let's go ahead and eliminate there being any kind of voltage being fed down to the amplifier from any of these op amps or anything up in here. So I'm going to pull this out and we'll see if anything changes. So give me a second. I'll get this connector loose and I'll bring you back. All right, so as we come back in, I went ahead and took out that input-output board, disconnected the ribbon cable from it, and disconnected the power altogether. So this board is no longer an influence on the main amplifier here, and we still have voltage. I've got a little test light, 120 volt test light hooked up on one side, and we're still seeing a negative 37.5 volts coming out of this thing. So what it looks like we have going on is either one or both of these output devices has shorted and sending voltage to the speaker outputs. From what I can see on the top side here, everything looks fine, everything checks okay. There doesn't seem to be anything open that would be causing an issue. So I think the next step, let's go ahead and get this entire heatsink and this board out, get it flipped upside down, and possibly go ahead and remove one of these devices one at a time, or these devices one at a time, and see if we have one or both of them that's shorted. And the thing is that because of the fact that they're top and bottom soldered, it makes it a little tricky to get them out of there. But we'll take our time and we'll get them out and see if removing one will get rid of the voltage on the output. So I'm not sure, since both of them share the exact same VCC line and several other lines. If one was shorted, it could influence the other, and you would see it on both sides, not just one side. So let's go ahead and do that. I'm going to go ahead and remove this board. We'll get it flipped upside down and see if we can start the process of getting one of these things removed. So give me a moment for that, and we'll pick back up. All right, let me go ahead and bring you back in here and get you caught up. As I have a tendency to do, I kind of got ahead of myself and forgot about the video a little bit, but that's okay. I'll show you what I've got accomplished. First thing I did was went ahead and removed one of the output devices. Basically what I wanted to do was see if I could detect a short on a couple of the pins, and particularly the output pin. And I did. So I went to this one, which was still attached to the board, and I had a short there still. So I went ahead and removed the second one, and I went ahead and spared you the 20-minute process and foot of solder wick needed to remove both of these devices without damaging any of the double-sided traces. So the board looks pretty good. I was able to get them out with no trouble. One of these boards that have double-sided traces on it, and you got a device like this with staggered pins, what my usual method is, especially if there's a hole blown in it and I know for a fact that it's bad, is I'll snip the pins off and just pull them out one at a time. But in this case, since I didn't know, I didn't want to damage the part until I was able to confirm that there was an issue with it. And as far as determining if there was an issue in it, we went to the data sheet and pulled up an LM3886. This is a component from National Semiconductor, as it turns out. And in particular, what we want to look at here is and this thing is getting us a pretty good glare here, it looks like. But what we want to look at is we want to look at pin 3 and pin 4. If you remember, we had a negative voltage on both speaker outputs. So what we really wanted to see is, do we have a short between pin 3 and pin 4, the speaker output and the negative side voltage input. So let's go ahead and I'll see if I can zoom you in here a little bit. And we can still get the meter in there. And of course, we're just looking for pin 3 and pin 4. And since they're staggered, 1, 2, 3, and 4. So 3 and 4 are basically up and down from each other. And there is a short there. No question about that. But then we get to the other device and we got the exact same problem. Dead short. If we look at the ohms, and if we go over here and check this one, so a little different. One shorted a little harder than the other one is. So I'm not sure what could have occurred in the electrical failure at his house that would have caused this, unless we had an over voltage scenario. I suppose that could have caused an internal short if he had an instantaneous over voltage situation. That could have caused the problem, but at this point I'm not real sure. But what I am sure of is both of these are bad. So I think the next step is let's go ahead and source a couple of these, and we'll replace them, and hopefully that'll get us back up and going. Until we get these replaced, I can't really tell if there was any op amps damaged or anything else damaged on that input board because we don't have any sound. So we'll have to get these going and see if we can go from there and find out what's happening. But these look pretty standard devices, and we should be able to find a couple of these. I may even have one. So I'm going to go ahead and work on that. And once I've got a couple of fresh parts, I'll bring you back and we'll install these. And we'll see if we can get his amp up and going here. So give me a little bit for that, and we'll come back in a few minutes. All right, so I'm picking back up with you. And as it turns out, I don't have that device in stock, but I did pre-order a couple of these when he originally sent this amp to me. I did a quick evaluation of it here on my bench, and once I measured that negative output voltage on both speaker outputs, at that point I figured that we would probably wind up right here. So I went ahead and ordered a couple of them just in case we needed them, and as it turns out we do. So we're going to go ahead and get these installed and see if we have anything else going on. It's very possible there could be something else wrong with it. If there was a strong enough power surge to wipe out both of these, then it's possible there could be multiple one or more op amps in this thing that smoked. So we'll need to get this going first. So I think what we'll do is I'm going to go ahead and just tag both of them in from the top real quick. Just one pin each. just to kind of show you my method for doing that. And these pins are perfect on these. And so they fit right in those holes beautifully. And of course, if you do a measurement between pins 3 and pins 4 now, needless to say, there's not a short there. So we'll drop those both in there, and I'm just going to tag in a pin on each side just so we can get it held in place, and then we'll go to the bottom side and start working on it. Now that we've got those secured in place, when we flip the board, they won't fall out. And so we can really go to town. Each one of these has a Schottky rectifier connected to the positive voltage input to the output side of the device. Okay, there we go. Now we should be able to just go to town on these with not much trouble. And even though they are double-sided traces, you'd be surprised how little solder you need to hold it in there. And that looks to be it. Let's flip it over and we'll take a look at the other side of it. I'll probably come along here with a Q-tip and maybe clean up some of the flux just so it looks more factory. But if you take a look here, you can see they're in there. Got a good bead of solder on everything. And like I said, this is a step that is not required, but just something that I always do. We'll just clean the flux off the board, kind of give it that nice factory look to it. These would operate just fine as they are. You wouldn't need to do this step. This is just something that I do. And the shinier the board is, the more this flux seems to be evident. And so, therefore, it makes me want to clean it off even more. looks pretty good. There's a couple of little spots here that if you really wanted to be picky, you could touch up, but I can assure you there ain't gonna be any issues with any of the connections on this. But yet here I am touching them up, so. All right, I think I'm gonna go ahead and clean this one up, and then we're gonna get it mounted back to the heatsink. Even though these packages are the insulated packages, we're gonna go ahead and still use the insulator and the screw hole insulator. That way we'll have a good seal between the device and the heatsink. So I'm gonna go ahead and finish this up and we'll get it attached back to the heatsink. We'll fire it up and we'll see if we have a amplifier that no longer has 38 volts on the speaker output. So give me a moment for that and I'll bring you back. All right, so picking back up with you, went ahead and got our devices mounted to the heatsink, got everything put back together. First thing I did when I fired it up, obviously no speakers at that point, just checked our voltage on the output side. No trouble whatsoever there, and it is working with no problem. I'm surprised there wasn't something damaged up here. But I've had a chance to take a look around this amplifier and I have discovered a couple of things. The first thing is I was looking at these wires in the beginning thinking that these were part of the control circuit on this power block here for the power coming in. As it turns out, that is not correct. These two are simply for the LED that's illuminated in the front when you turn it on. And one of the things that I've noticed here is that the control circuit in similar amplifiers, you would have a relay here. You input your own voltage, whether it be 5 or 12 volts. That relay will click, restoring power to the front side of the transformer and then turning the amplifier on. That's not how this works. All this does is this mutes the amplifier. So we have the unit turned on right now to where it will only work if you input a voltage through here. And look at this. There's our negative 35 volts on the negative rail. Positive 35 on the positive side. And that's not all. All the voltage up here is there. Positive and negative 15 volts that supplies these op amps. That voltage is there too. All this is doing is putting the amplifier in mute. So if you have this set up to where your receiver is turned off, the amplifier is technically still on. There's power at both output devices. There's power to the input board. Everything is there. The only thing is it's being held in mute. So once the voltage enters, it supplies whatever voltage is needed. Like it said, 3 to 15 volts for the mute circuit, and takes it out of mute. But otherwise, the power is always there and it's always working. So kind of interesting the way they did that. Otherwise, this thing seems to be just fine. There doesn't seem to be any heat issues at all. I've ran it for quite a bit now, and it seems to be doing just fine. So I think we're going to be okay. I'm going to go ahead and put it back together, and we'll do a final play test on it. And since he uses this with a set of bookshelf speakers, I just happen to have a set of Mirage bookshelf speakers I took out of my house that I'm going to get rid of. And we're going to hook it up to this, and we'll demo the amp with those speakers. So stand by for that, and we'll do a final play test on this one. All right, let's go ahead and pick up one final time, taking a look at this B&K amplifier. ST-260, I believe it was. So we got a pretty nice, quick and easy repair on this one. Well, we got an easy repair. I don't know how quick it was after trying to preserve the two output devices without destroying them before I even knew that they were bad. So that can be a little time consuming removing those. So I got this set up with a couple of Mirage bookshelf speakers. I just pulled these out of my house. I went to some in-ceiling speakers to kind of lighten the footprint of audio equipment in the house versus out here where there's tons of it. These are a very nice set of speakers. Have a good sound to them, good tight bass. I got the laptop jacked into the bench receiver, and we're coming out of the bench receiver's headphone jack going into this B&K. And that way we can get some really good highs and lows. And for what the amplifier is, it's actually very powerful. I believe I read these chips are maybe 38 watts for 8 ohm load and maybe 60 something for a 4 ohm load. So the amplifier is pretty capable of driving a very nice set of bookshelf speakers without any issues whatsoever. So as we get ready to close this one out, I want to thank Scott. I appreciate you sending up this B&K for me to check out and get going for you. Thank all the viewers. Appreciate you guys checking out the video this month, as well as all the videos on the channel. And so as we finish this one up, let's check out a little bit of Crooked Man from Patina, Red Dragon Cartel. I'm going to crank this up a little bit and we'll check it out properly here. As always, thank you guys very much. Appreciate it.